Let's go through Lickers 2011. Find if array can be sorted. For this question, it gives us integer nouns. And in one operation, you can swap any two adjacent elements if they have the same number of bit of sets, a set of bits. You are allowed to do this operation in any number of times, including zero. Return true if you can sort the array, otherwise return false. So it means if we have this array, right? If the two numbers they have the same bits, same number of bits, then they can swap. If so, in this case, if we find, for example, number A and B, they are not they do not have the same number set. That means we should this kind of array they are not able to swap between these two numbers. That means this kind of array can be divided into different segments by, for example, this one means all of the numbers in this kind of segment, they are able to swap. And they need to have the bits count to be the same, right? So in the end, what we do is that we need to divide this kind of array into different subarrays or different segments. Each segment have the same number of bits. So we can write a help function count bits, right? And iterate from I equals to 1 to n, trying to see if the bits count of num I equals num I minus 1, right? If it doesn't equal, means we find a divider, right? In this case, what we need to do is that we have a segment here. This is I, and the I minus 1, right? And is belong to the previous segment, and this I belong to this segment. And during in order to have this array to be solid, that means the previous segment, the largest number should be smaller than current segment, the smallest number, right? So we can do this is have three variables. One is called previous largest, and another is we call what's the current largest, right? And also for every number, we iterate in our current array. We compare this number to the previous largest. If current number is smaller than previous largest, then that means there is a number in this segment is smaller than previous one. It will return false. If all of the numbers in current one is greater than previous largest, then means we are able to have this kind of the smallest in this current is greater than the biggest in the previous. Then we can do in by sort to make the array swap by to make array in a solid order. So let's write code for this. We're going to have int n equals num stop length, and we need a current largest, right? Let's set this as 0, and we can have a previous largest. We can set possible as 0, right? And we set this one because for the previous one, we set for the we will set the previous largest to largest when we find a new segment. That means this num I the counts done equal to num I minus 1, right? We find a new segment. Then we'll have the previous um, set to equals to L, right? And then this L equal to the new number. Um, so what we do is that we'll say for int I equals to 1, I smaller than n, I plus plus. We'll say if get a bit count nums I doesn't equal to get a bit count nums I minus 1, right? Then that means we are at a separator. We go to our new segment. Then we have previous largest equals largest. And we'll have the largest equals new nums. Else, that is means we are still in our current segment. Um, we'll say if in this case, what we are going to do is that we'll have L equals max dot max L and nums, right? And if we have nums I, um, we can write this outside. If we have nums I, which is smaller than previous largest, we just return false. Otherwise, we just return true. And then we need a help function of it int get a bit count int num. Yeah. So what we do is set int result equal to 0, while this kind of num prime equal to 0. We have num and equal to num minus 1, right? And we have result increase. This kind of formula is just remove the um, lowest bit from this num, return result. Um, the Python code will be very similar. Mm, we are going to have n mm, l here n equals length nums l equals nums 0 and pr equals 0, right? So what we do is that for I in range from 1 to n, if we get a bit count nums are down equal to get the bit count nums I minus 1, right? Then what we do is that we're going to have PR equals previous largest equals this largest, and our current largest will be nums I, right? And we'll say else. That means we are in the segment. we have L equals max L and the nums I. And what we say is that if this kind of nums I is smaller than previous largest, then we return false. Otherwise, just return true. Need a defined 8-bit count. Now this is the unit, and returns int. So what we write is the result equals to 0, while this num then equal to 0. We're going to have a result with the class equal to 1, and num use and or num minus 1, and in the end return result. The time complexity will be O n, because we just iterate this array not once, right? And the space is constant. We don't have actual space.